Okay, when you guys have a vertical stretch or shrink, you will have a function, any function, a parent function, and you will have that function multiplied by a number. When we do anything vertical, everything vertical is common sense. Everything vertical is on the outside of the function. So vertical is outside. It's also common sense. So if I have a number that's bigger than 1, give me a number bigger than 1.
2.
Okay, 2. If I multiply anything times 2, it's going to get bigger. Anything bigger than 1 is a vertical stretch. Numbers that are between 0 and 1, give me a number between 0 and 1. 0.5, 1/2. If I multiply by half, if I multiply anything by half, that's getting smaller. Half of something, that's getting smaller. Why would it be between 0 and 1, greater than 1? Why doesn't it include less than 1 or less than 0?
Man, you're gonna make me fail.
I know, right? Why, Ian? Because if we have a negative number, that is a reflection. That is a completely different transformation. If I have like a -2 absolute value of x, if I have -2 absolute value of x, the negative is the reflection, the 2 is a stretch. So you look at them separately. Now, horizontal stretch or shrink, anything horizontal is on the inside, and anything horizontal is opposite operation. So before I explain this, if I have like y equals absolute value of 2x, where I've got 2 on the inside, that's going to be horizontal. What is the opposite of multiplying by 2? That's dividing by 2. But we don't really like to divide. So instead of dividing by 2, what's something I can do? Instead of dividing by a number, what also could I do? Was that Katie? Good job. Multiply by its reciprocal. So that's really what we're going to do, is when we have a horizontal stretch or shrink, when we have a number multiplied on the inside, technically we're dividing by that number, but really we are just multiplying by its reciprocal because it's easier to multiply than it is to divide, especially when we have fractions. So if I multiply anything by a half, that's going to make it smaller. So there's a 2 sitting in there, but that's a horizontal shrink. Or if the number is originally, let me give you another example, y equals absolute value of 1/10 x. If I multiply by the reciprocal of 1/10, that would be multiplying by 10. So that would be a stretch. Even though inside it's 1/10, it's opposite of what you think. So that's why it says if the b value is between 0 and 1, that's going to be a horizontal stretch. If it's greater than 1, it will be a horizontal shrink. All right, so we'll do, why does that look like the same question we had yesterday? These are the same questions we had yesterday. This one's not. We already did these two, didn't we? No, you know what? I'm getting confused because I teach 3 classes right now, and all my 3 classes are doing transformations, but at different times. We did this in a different class, not in this class. Okay, here we go. I am having the best day ever. So we look at this equation. The first thing I'm going to do is I'm going to determine that this is an x squared parent function. This is an x squared. That's the parabola. I'm going to fill out my table. This is not our notes?
Yes, it is. Yes, it is.
Hey, I thought I was wrong, honestly. Like, I've been having that day.
It says notes about it.
She might just have the other one open. Because there's 2 on the same module. Did we have the wrong one? Did we have yesterday's open? Oh, that's what I did earlier. Sorry, hon, I did the same thing earlier. Okay, I am writing my I think I'm going to be re-recording this video next. Okay, I'm doing my parent function. And there's my parent function. Now we're going to write our transformations. So in our new function, we have a 2 in front of the x squared. Is the 2 being squared? Jacob, is the 2 being squared? No. So is the 2 vertical or horizontal? If it's not being squared, then it's on the outside. So this is a vertical. And because it's 2, it's going to be a stretch. We write a vertical stretch by a factor of 2. What is wrong? Write a vertical stretch by a factor of 2. And then the -4 is translate down 4 units. So we've got 2 transformations. Both of these are vertical. One of them is, by the way, when it says by a factor of 2, that means multiply by 2. That's what that means. So we are multiplying by 2, and then we're also subtracting 4. What has to come first by order of operations? Multiply or subtraction? Multiply comes first. So in my table, they're both vertical. So I'm going to multiply first by 2. Then I will subtract 4. So when I do that, I get a couple points that don't fit on my graph, so I just won't graph those. So -2, 4, -1, -2, 0, -4. One nice thing about when we graph parabolas and absolute value, ooh, that was ugly, is that they are symmetric. So once you plot a few points, you just have to mirror the rest of the points. What are you confused about?
On your thing.
What's the help me?
I don't even know how to confused because I don't know. I don't want to be wrong.
You could be wrong. I'm wrong all the time.
So you're on -4 then.
0, -4.
Yeah.
Yeah.
Where did you get?
Where did I get that?
Oh my gosh, I was reading it. Never mind. See, this is why I don't want to talk.
Okay. But you need that to figure out what you're doing.
Yeah.
You need to just get it out. One reason why transformation tables are awesome, well, awesome, but they're better than just plugging in random numbers, is because you will always get the vertex, which is an important part of our parabola, that part where it turns. You're always going to get the vertex. It starts at 0, 0, but then with transformations, it ends up at 0, -4. So just in case anybody else is confused, I graphed the outside x's and the outside y's. Those are the ordered pairs that I graphed. Okay, now section 1.3 was to write the domain and range in interval notation. So we're still practicing that because that will also be on your quiz. The domain for all parabolas is all real numbers, but we write it in interval notation by saying -infinity to +infinity. And then the range, we look at the lowest point. And the lowest point is a -4. And then the highest point, it goes on forever. So just +infinity. Remember, in interval notation, it cannot equal infinity, so you have to use a parenthesis. Yeah.
So I have a question. So
Yeah.
does it matter like which like side you put it on?
I don't know what you mean by side, hun.
Like,
Are you talking about the range?
yeah.
Yes, it always goes from least to greatest. Always. Okay? Yes.
So is the bracket always gonna go on the side that has like the number and not the infinity sign?
The infinity will never, ever, ever, ever have a bracket. Sometimes the number will have a parenthesis. It depends if it equals that number or if it gets close to that number but doesn't equal it. So that actually equals the number. Here it is. It's equaling that number, so it gets a bracket. Never, ever can it equal infinity because infinity is not a number. Just means it keeps going on. So we can't equal that. Does that make sense? Okay. What?
Like if it's like an open dot.
Right. If we were graphing a number line or just when we did the piecewise functions and we had an open dot, that would be a parenthesis, where a closed dot would be a bracket. Yes, Ian.
Is the infinity always second in the order correct?
Second, is that what we said?
Yeah, so like.
Infinity, a positive infinity will always be the last thing because that's the last thing we can have. Now,
52.
some won't go to positive infinity, and in that case, it might start at negative infinity. Here, the next one actually I think does that, so we'll see it. But some won't end in an infinity. Okay. All right, let's look at question B. Question B has something special about it. Now, yesterday I put up, it's not open anymore. Yesterday I put up a transformation formula, and I'm going to go open that back up just so I can refer to it. Yesterday, we talked about this transformation formula, and you can see I was writing on it because of, we talked about how the negative has to be pulled out of the -3. You can't have a reflection and a translation in the same works for stretches or shrinks. If you have a number in front of this X and it's not factored out separately from the translation, then it's going to be wrong. So you need to factor it. So with this one here, I've got this 2 that is not in its own separate parentheses from the X plus whatever the translation is. So we're going to factor it before we start. We're going to factor the 2. So I'm going to take that 2 out like GCF. I'm going to rewrite my equation. I'll have negative parenthesis 2, a second parenthesis, X plus 3, parenthesis squared minus 1. So if you don't do the factoring step, you're going to have completely the wrong translation. So you've got to make sure that you separate that stretch in front of the X from its translation. It will never come out of the squared, but it has to be separated. So from here are transformations. I'm just going to go left to right. The first transformation I come to is the negative sign. So that is a reflect. In the, who knows which axis that one is? It's x-axis. It's one or the other, right? So why is it x-axis? It's outside, which is vertical. But if we do a vertical reflection, here's my heart, and it's going to reflect vertically. If it's a vertical reflection up and down, it's reflecting over that x-axis. So we got to reflect in the x-axis. Then we have this 2 next. That 2 is a horizontal. And it's either going to be a stretch or shrink. I'm going to leave a blank here for just a second. By a factor of, and then we're going to figure out that factor first, and then we'll be able to tell if it's a stretch or shrink. So horizontal is always opposite. Instead of multiplying by 2, what would I actually multiply by? half. We multiply by its reciprocal. So this is going to be a factor of 1/2. That's what I'm multiplying by. So now looking at that 1/2, is that a stretch or a shrink? Half. That is a shrink. Half, if I multiply by half, it gets smaller. So the words make sense with the number after you flip it. The words are going to all fit, like that's going to all match. It's the equation that doesn't match. What do I have next? That +3. So that +3 is horizontal. That's a translate. 3 units. So if it's horizontal, it's opposite. So instead of +3, we're going to go -3, which is which direction? Left. And then the last thing we have is a -1. So and down 1, because the vertical is just exactly how you see it. It's common sense. This one's x squared, so I'm going to go ahead and make my parent function. Oops. The order that we write our transformations will be anything that is multiplied is going to be the first thing we do. So on the y side, I'm multiplying by a -1. On the x side, I'm multiplying by a 1/2. Then after multiplication, it's adding or subtracting. On the left side, I'm going to be subtracting 3 to make it go left. On the y side, subtracting 1 to make it go down. Well, now I just have math to do, some quick math. One thing that's good about parabolas is they are symmetric on the y side. And then on the x side, if you pick these points, they always go up by the same amounts. So when I start having fractions and stuff, if they always go up by the same amounts, it helps me go a little bit faster. And I know the part that I'm going fast is like this math part. I just want to make sure you guys have seen me doing the tables, seen me write the transformations, have the domain and range, and then if obviously you should be able to find the numbers on your own if I'm going too fast. So I always graph the outermost x's and the outermost y's. And you guys, you don't have to write them in improper. Like you could write -4.5. That's totally fine. But if we do it in Canvas on a quiz or something, you're not going to be able to write 4.5. So I am modeling how you would write it in Canvas. You would need to write it as an improper fraction, -9/2. Okay. You potentially could write -4.5, but when you start getting numbers that don't have a decimal that ends, then you can't really write the decimal form in Canvas. So I'm just modeling it by using fractions every time. But -9/2 is -4.5. It's down here though. I think I did something wrong. -4 is, oh, yes, I didn't read it correctly. Two and a half. Okay, so I just had to zoom out. You might not be able to see my numbers super clearly because they're small. But like I said, the biggest thing that I want to make sure that I do with you is the writing the transformations, the factoring, and making the table, not necessarily that you can see every tiny little number in the table because you can multiply on your own, right? Fingers crossed. Okay. All right, so the domain. So the domain is how far to the left, how far to the right. Parabolas, quadratics are all negative infinity, positive infinity. The range would be how far down to how far up. So this is what I was talking about before. How far down does this graph go? It goes all the way down to negative infinity. So that's the first thing I write. And then how far up does this graph go? So it goes up to -1. It does equal -1, so I put a bracket. So that'd be an example where it doesn't end with infinity because it doesn't keep going up forever because it slipped down. Okay, question C. We're going to be writing our transformations. This is a square root. So I'll have 0, 0, 1, 1, 4, 2, 9, 3. I'm picking points that I can square root. Picking points that I can square root. Transformation. The 3 out front is a vertical stretch. By a factor of 3. Vertical stretch by a factor of 3. When you do take your quiz on this, you will be like filling in blanks for transformations because yeah. So make sure you know the correct terminology. Yes. Yeah. So that one would have like a blank for stretch and blank for 3. The next one, I look underneath my square root and I've got 2 things happening. Are they separated in separate parentheses? Is that 1/2 and the x minus 2 in separate parentheses? It is not, so we have to factor. And I'm factoring out a 1/2. So I'm going to have 3 square root 1/2 parenthesis x minus. So we have to take 2 and divide it by a 1/2.
So because if there's anything in front of x, if it's
Yes.
under the parentheses, then we have to factor it out.
Yes, exactly.
Why?
Because you have to have that number, if it's a stretch, a shrink, or a reflection, you have to take it out of the translation. Because this translation is going to be a certain number, but once you apply half of it, it changes the number. So we have to separate that out so we get the translation without whatever was applied to it. I don't know, probably didn't make a lot of sense, but I can show you how they're different. Question,
No, but I
PJ?
was-
The translation has to happen
It's the way it's
first,
written.
and also in the line item.
Right, right.
You have, like, basically, you have to do the translation before you do the
Before you-
the stretch.
If you don't take it out.
Yeah,
Right.
okay.
But we're trying to make it consistent. We're trying to use order of operations so that, we always use our math rules. So that's why we factor it out first, because otherwise it would be backwards. So what number is 2 divided by 1/2? 4. Yes, we're trying to get through our stuff.
I don't think
I know, right? No.
Or 2 or 3.
So we have a horizontal something by a factor of, so if it's a 1/2 in here, instead of multiplying by 1/2, I'm going to multiply by the reciprocal of 1/2, which is 2. So if I multiply by 2, is that getting bigger or smaller?
Bigger.
Stretch. And then we have what?
Oh, never mind. Sorry.
And then we have a translate 4 units to the right. So in our table, and we don't have to totally finish this one, but in our table, we would do multiplication first. So we would multiply our y's by 3 and our x's by 2. And then 4 to the right would be on the x side plus 4.
Wait, aren't you supposed to get -2 when you multiply 2 by 1/2? Not -4, or because it's a negative, you get
Are you asking about this one right here?
up in like after you factored, you get -4 from dividing
By dividing by 1/2, yeah. And then, but are you asking about why I wrote right?
Well,
Or
no, I got that.
okay.
How'd you get 4?
Oh, how did I get 2 divided by 1/2 and got 4?
Yeah.
So 2 divided by 1/2 is the same thing as 2 multiplied by the reciprocal of 1/2. How many halves fit into 2 wholes? Like think about cookie.
4.
Yeah,
Cookie?
a cookie.
Why would you think about a cookie?
I don't know, because they like always. I was gonna say
That's really
pizza, but
small.
Yeah, pizza would make more sense. I don't know because they cut them into.
I know, but like who's
Aren't
eating
you a
2?
math teacher?
Yes, but who's eating 2 whole pizzas? Who's eating 2 whole pizzas?
I am.
Okay, guess how big they are. That's good. It depends. So anyway, I set up the table. I went through the transformations. I can't do the domain and range without seeing the graph, so I'm going to skip that. We might have to finish these notes tomorrow. Oops, where did I go? What did I do? Okay, so guys, we'll probably have to finish these notes tomorrow, but we got to the part where you can do the graphs. We didn't get to the part where you're writing the equations. So we'll do the writing the equations tomorrow. In your assignment, make sure you do the graph part first, and then we'll do the equations after our notes tomorrow, okay?